Welcome to another Transforming Assessment webinar series. It's the 7th of October 2015. Today's speaker is Associate Professor Kim Bryceson from the University of Queensland, and she'll be talking about outdoor sensors for real-time data in e-learning activities. So Kim, would you like to begin, please?
Well, thank you, Matt. Thank you, everyone, for turning up online. First time at one of these webinar series, so I hope what I've produced is of interest and of value, and that I've presented it in the right way, because it is a little scary doing things for the first time. But let's just get started. Outdoor sensors for real-time data in e-learning activities, or the Internet of Things at the UQ Gatton campus, at the University of Queensland Gatton campus, for smart science and agriculture education, which is really my passion. Personally, as a scientist, I'm the Associate Dean Academic for the Science Faculty at the University of Queensland, and my research background is a physics PhD followed by 10-15 years in remote sensing and then into agribusiness in the university. So my remote sensing stuff was industry and now agribusiness. So this project really has come about through all that remote sensing background, my agriculture, agribusiness interests, and combining the two. So I haven't got an agenda, but I thought I'd just launch straight in because I'm not sure how long this will take. But the project that we've got, and the project that I'm presenting, is really only halfway completed. So we've got two aspects: the establishment of a multi-sensor mesh network, which is called the Smart Campus Initiative, across the whole of the UQ Gatton campus, which is about 1,000 hectares of prime agricultural land. And that multi-sensor mesh network is measuring in real time any and all biophysical variables that might provide interesting data from an agricultural or environmental perspective. And I'll go into the components of this. I've called that the Internet of Things, and you'll see why in the next couple of slides. The second aspect is taking that real-time streaming data from the multi-sensor mesh network and developing problem-based learning modules for integration with UQ's learning management system, which is Blackboard, which I'm sure most of you will have some form of experience with, even if it's only just having a look and seeing that you don't like it. But this links in with a situational living laboratory e-learning approach that I'm trying to develop, and it is the second part of it, is the component that we haven't started yet, but we have got funding for that. So I can go and tell you a little bit about what we're doing there. So the multi-sensor mesh network, or the Internet of Things, it's a Vice Chancellor's initiative. We got some funding, seed funding, at the end of 2014 to establish this Wi-Fi-enabled multi-sensor mesh network, which will and does currently measure every biophysical variable useful to ag information systems. It also includes remotely located remote cameras for imagery collection and motion detectors. So in that we can actually look at some animal-related stuff as well. So, following on from that, the Internet of Things definition, which sort of links into that whole smart campus, smart multi-sensor mesh network, a network of physical objects that contain embedded technology to communicate and sense or interact with their internal states or the external environment, and then with the ability to transfer that data over a network without requiring human-to-human or human-to-computer interaction. Now, the reason I've looked at this multi-sensor mesh network as an Internet of Things is because that is exactly what we're doing. We've set up a network of physical objects, or sensors, and we're receiving that data in real time and sending it across networks that can be accessed across the world, actually. We've made it an open system. And it's password protected at the moment, but will be available to anyone and everyone, particularly those on EduRoam, the academic internal internet, but a little bit more about that later. So the multi-sensor mesh network is a smart campus initiative, and I've called it the Internet of Things because it really fits that definition quite well. So here we have the UQ Smart Campus, just a diagram showing it, and I'll go into this technology a little bit more. We've got sensors and the smart units from Libelium, Libelium is a technology company in Spain. They have been significantly working on sensors and plug-and-play technology for using in environmental conditions. They have got smart agriculture, smart water, smart environment, smart cities, smart security, and others, and into these essentially little boxes, which are in actual fact computers. You can plug and play appropriate sensors. You just plug them in, and they come ready to sense straight out of the factory. We've got them dotted around this campus, as you can see, in the various locations: the feedlot, the piggery, the dairy, the horticultural field, the equine foaling unit, and co-located equine paddocks, our wildlife enclosure, which is for endangered native fauna, and of course the built environment, which is actually the campus, which is essentially all the buildings and the walkway, which used to be a major road through the campus, but which has come many years ago now, probably 20, 25 years ago, was turned into a walkway for students. So no cars go through the centre, but it's all about student movement, the issues of noise, sun, radiance, etc. The Multicenter Mesh Network System collects data continuously and in real time from sensors measuring multiple biophysical variables and collects remotely sensed imagery as well. Saved into an SQL database on a UQITS virtual server. And I'll tell you how we set this up with our Information Technology Service, or ITS guys, who have been very, very helpful. And in doing that, we've tried to make this a sustainable system so that down the track, it will be part of a well-maintained overall university IT system. So I'm not, my group is not going to have to maintain this. It will end up being part of the standard ITS system, which makes it much more sustainable long term. We are making all the data freely available for education and research projects around the world. Keep forgetting how to click these things. So here we've just got a schematic. So the Smart UQ Gatton, or the IoT project, managing spatial variability, and we have a GIS remote sensing lab which I run. Farm management, of course, because the farm is an operational working farm. We have properties and facilities, so UQ's property facilities, environmental systems, which they've been very interested in this data. So once again, I'm incorporating people who are established within the university system, so it becomes part of something that will be maintained because it's seen as valuable to the actual operation of the university, as well as an educational research resource. So automated weather data, we've got 20 automated weather data collecting systems, local weather monitoring and climate change over time. The e-learning component, which I might actually leave until we just go through the other side of things, because that's that second part of the project. In animals, we've got a beef herd, we've got a feedlot, we've got a dairy, a large dairy, which the state government uses a lot for their research. A piggery, which is being rebuilt currently, state-of-the-art piggery, a wildlife enclosure, poultry, and equine, a very large equine hospital here, the largest probably in the country, and it's associated with our vet school, but we also have academics working on equine physiology. The crop pasture production side of things, precision farming, and we also have in my remote sensing lab, we have a drone design and building capacity, which my students use and have done quite a lot of work on, soil mapping, record keeping, nutrient management. And in horticulture, we're looking at tomography or 3D CT scanning of trees and roots, green walls, microsensor soil moisture, logistics, post-harvesting, cold chain, and industry-specific drone technology. So we're looking at working with the horticulture industry, which we're doing, the wine industry, which we're doing, broadacre cropping, which we're doing, organic companies that sell organic products like beer tractors for high-value fruit crops, using organic, what's called flat asset management in the realms of estate management. Now, the e-learning side of things is about this whole real-time data collection and how do you get that information into the learning management system, both the undergraduate, postgraduate, and RHD cohort, research high degrees, and of course, small short courses. So just a schematic. Again, sorry, this is a bit of a repeat, designed to encompass everywhere on the UQ Gatton campus. The network also includes water level and chemical content of the farm ring tanks, which in an Australian farm are very large. They're border dams that are used for collecting water, and Lake Galletly, which is an environmental part of an environmental park that's on campus. We're quite interested in this Lake Galletly area because it helps to manage the water system on the campus. We have also just very recently included our wastewater management system, which is water reticulation and essentially sewage farm, and we will be using these smart water sensors to look after that. So we bought the technology, we built the first section, which is the built environment, and installed it on campus. We've got real-time biophysical data streaming in, and this has been established and running for the last 3 months. The SQL database has been designed and is running on a UQ virtual server at St. Lucia campus, which is 70 kilometres away, but that is where ICS are essentially based, but it has no issue. I mean, it's not an issue as to where the virtual server is based, because of course we can get access to it. And it's publicly accessible anywhere that has eduroam, although currently, because we're still in a little bit of development, particularly around e-learning, it's password protected. But I'd be happy if anyone is interested and wants to contact me to incorporate you into this project, because you know, I'm very interested to see how this data could be used by other people in other parts of the world for their teaching. We're also looking at developing online GIS, and that's started already. So the design of the wireless sensor mesh network, it has a mesh topology, so we've got a mesh here, and the mesh at the moment might be every 300 or 400 meters, but to add a much more dense mesh doesn't cost you very much. It probably costs around about $400, including the sensors for each little unit. So if I'm doing a horticulture experiment, so no, let's look at a pasture experiment, which is a slightly larger area. We've probably got 48 of these little units on a trial test of pasture, that we're looking at different types of pasture. You know, it depends. You can look at spatial variability, you can look at scale, etc. The sensors are multiple, and really any biophysical data that you wanted to collect, these little systems can collect for you. There's varying degrees of accuracy, and whether you want to calibrate them yourself or whether you get Labellium to calibrate them yourself. But again, they're not very expensive. They're by far and away the least expensive sensors of quality that we've been able to find from around the world. Labellium is also very happy to facilitate the development of anything that goes with these sensors. And it's very robust and low maintenance. As I say, it's plug and play, and literally if a sensor breaks, you unplug it and put another one in. And there's very little more maintenance that you have to do. So each little unit that you can put up, as you can see roughly the size here, is a hand in the box, plug and play up to 6 sensors per box. They're solar and battery powered, remote wireless programmable, because this is essentially a computer. The box is essentially a computer. Arduino-like software. Modular components, again, plug and play, take out what you want, remove, change. Because you've got a modular mesh network, you can take out components without it affecting the rest of the network, because it all flows in. Multiple communication protocols, Zigbee, Wi-Fi, 3G, and various different sensor protocols that you can see there, so that you can plug them in, the data into whatever you wish. It's a really nice system. We've got, how we connect this is through a Linux router. We can have up to 4 simultaneous communication links. This Meshlium here, this is the Meshlium, so you have one of these white units in amongst, you know, 10s or 20s, 30s, 50s of the smart agriculture boxes. So this is a lovely little piece of equipment that then you link in through to the internet via this box. And we've set up systems that enable us to make sure that if power goes down on one unit for whatever reason, we can keep that going, and same with the Meshlium. So that's probably not very interesting, connecting servers to UQ's system. So here's the smart campus and a project I'll talk about. So we've got the Michelin gateway, the moats or the units and sensors, and this goes through Wi-Fi edge-around infrastructure into the basic UQ, the UQ system, into a MySQL database, which we've broken up into various components that will take in the data. Again, we've tried to keep everything seriously simple, logical, straightforward, so that we can develop this up to something, or lots of things, depending on how people want to use it. The system can be used or the data can be used. So in GIS, so we're using ArcGIS software, and it's a simple set of layers essentially, but that data then comes in to a database like this, so you can see soil temperature, so this is the rainfall, this just gives you an indication of battery, soil, blah, 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 okay? So there's a whole series of those that you can have in. And the sort of data that you can pull out is one where we would, and this is an example only, where we would have 4 systems, these little orange boxes, orange rounds. I'm just seeing some chat. Is someone wanting to talk to me? I can. I'm quite happy if I know how to use this technology. But if not, I'll answer that question afterwards. Geoff, yes, I could have students in different programs contributing to different skills to the whole project. Absolutely, and we've got some electrical engineers that are very interested in this. I've got agronomists, I've got agricultural students, I've got, geography students, the whole shebang. Could easily be interested in this. Agribusiness as well, because I'm very interested in seeing how this information on farm, for example, creates a smart production system that then delivers into the agri-food supply chain and down the track to a better product to the consumer for a lower price. So there's an integrated approach to this. Listening to you typing, not bad for Melody. No worries. I'll just keep on, and if you need, we can talk afterwards. So, Smart Campus Project, this is dynamic data visualizer type example. We've got month September 2015. We've selected the sensor node 2, which is wind direction in this instance, which has given us some idea of the percentage differences on a compass base. So we'd say this was north up here, south down here, west and east, and so you can see the majority of wind in September. So during that month was around about the sort of southeasterly direction. We also have some irrigation and soil. So you can see here over a 30-day period, temperature and soil with rain coming in and humidity. So temperature, soil, and soil humidity coming in through here. And you can see that does actually relate very nicely to the rainfall that we were getting. So this is just one way that you could visualize that data, but quite a nice one. The second component of this on the left corner is from a drone. Yes, yeah. Oh, sorry, I forgot to say that. Let me just go back. Photo on the left is from a drone. As I say, we build and design drones in my lab. We've got about 6 or 7 specialized agriculture drones, but I teach a course called Precision Agriculture, and we have the students designing and building their drones and then flying the drones with very small little cameras on board that they can then take photographs and then analyze, whether they analyze it in something as simple as Photoshop, or we encourage them to use the Esri imagery, because we also then link it back to satellite imagery. So this is a remotely sensed piece of imagery here. The additional component of the ISC is our Barbara project. We have 1.7 million YouTube beef training facility project, another internally funded project. It's on 350-acre farm blocks, 10 kilometres away from the UQ Gatton campus. We've put in a multi-sensor mesh network there as well. It's been designed along similar principles to the Smart Campus Initiative. And really that's about farm risk assessment and management decision making, particularly in the area of pasture management and animal welfare. And this is where the cameras and the movement detectors come in quite significantly. The network's been designed and technology bought, and it will be finally and completely implemented by the end of this year, and then integrated into the Smart Campus project. And because it's all Wi-Fi linked, the Multicenter Mesh Network, or IoT, just simply sees it as another part of the IoT. And the long-term goal is to set up this RRF facility as a living laboratory for students and researchers working in the pasture and animal management areas. So here are the paddocks. We've got about 350 acres. We've actually fine-tuned that to this area here. And hi, David, good to see you. Oh, look at your involvement. We will be doing some very intensive different pasture type experimentation. And this network will also have automated drones being controlled from the YouTube Gatton Farm Office, and they will fly around this system on a regular basis, mission controlled. And the idea is that a drone will go from A to B, so it'll go from here to here, and then another drone will come out of and then land, be taken out of the air by a robotic arm, plugged back into the landing bay, which will then be serviced by solar power. It will recharge its battery, but at the same time another drone will take off, go to the next landing bay. There will be 3 drones in this area taking imagery on a timed basis. At the moment, I mean, we're collecting our test data on, seconds. Well, we're just generating too much data. So we'll be bringing that out to probably every imagery. I don't know, probably every 6 hours. With that sort of thing still has to be worked out. But it's a nice system, again, a very easy system. The drone is probably the most risky component, but we have been designing and building these drones now for 18 months, so we're fairly sure that we're okay. The second part, so that's the IoT and the system that has been set up, and that's continuously being added to. We've got a rice project that's just about to start, where someone's done the genotyping of 400 genotypes of rice, and they want us to look at the phenotypes in terms of the biophysical environment and look at imagery, and they want us to look at specifically sensing one of the volatiles that come off rice, which has been found through metabolomics in the food science area, and we're just about to start that with buying some more technology from Marbellion. So that's the IoT system, but what we're doing now, the situational living laboratory e-learning component, which I guess is what you're possibly interested in here, is to develop a multifaceted web-based interface, or many of them actually, including mobile phone apps, with the IoT technology of a small campus, and link that into the learning management system Blackboard to produce innovative teaching modules for a number of courses across the science faculty that use biophysical data in their teaching. And you'll see, if we just move on, we'll see how many courses there are. Well, I'll give you a hint. There's about 32 courses with 15 academics across 9 programs, that's degrees, and across both campuses. The St. Lucia city-based campus and the Gatton campus, 70 kilometres away, basically down the road. So that's quite an ambitious program. Why we want to do it is because young people today use electronic equipment to access information as never before. So really, we need to be looking at educating these kids in their environment, and the availability of real-time biophysical data through Blackboard will bring the outside biophysical environment into the student world in an interactive, hopefully constantly engaging visual way. I'm constantly up against the fact that agriculture is not a well-liked area to get into for young people. They'd much prefer to sit in the local city cafe looking at their mobile phones having a cafe latte. Now, the thing here is that they've got to understand that the cafe latte actually has rather a lot of agricultural production involved in getting it onto their table. And so how do we engage them to understand that agriculture is so important to their well-being? but also do it in a way that they're interested in, not your usual stand and deliver, but really bringing them into that agricultural environment and using technology in a way that we haven't done before. And we believe that the project will allow us to develop a fresh educational curricula. We've got 4 new named degrees commencing in 2016, the Bachelor of Sustainable Agriculture, Bachelor of Equine Science, Bachelor of Wildlife Science, and Bachelor of Veterinary Technology. And all of those new named degrees will have some of this real-time biophysical data in them. We want to get students to use real-time data and technology for improved research and industry-led land management outcomes, because again, we're looking at that whole sustainability option, and students love the issue of sustainability. So if that's what we can do for them, so much the better. And to be honest, we want to establish a brand as the premier agri-science node of an Australian network of digital tertiary education providers. Why not? We've got to aim high. How? Well, I learned on Wednesday that we have been successful in getting a technology enhanced learning grant for around about $200,000 odd, 18 months worth. And what we're going to do is we're going to engage a programmer and a graphics designer, plus an educational designer, which we have in-house, to work with 16 academics, 34 courses, 9 programs. Sorry, I thought it was 15 and 32. We've got another academic in there. 9 programs across 2 campuses, as well as our technical staff, which include the IT guys and our property and facility guys. As I say, they're the ones that are interested particularly in sustainability and the water management issues on campus, but that can then deliver into the students. And what we're wanting to do is develop web-based interfaces, mobile phone apps, and problem-based learning modules using the real-time streaming data. And, you know, create innovative teaching models that will grab the attention of students, that will make use of the real live environment to enhance their learning. My wish list for that was, in addition, to have some interactive digital signage, so smart touch screens. And we haven't got that yet, but it'll just be another pot of money that I have to source. It couldn't come out of the technology enhanced learning grant because that was how it had no assets. You couldn't buy any assets when you applied for that learning grant. It had to be something about education, and you could employ people, but you couldn't buy assets. So the smart touch screens, which will just simply link in to the IoT and the Blackboard modules, so that that'll be strategically placed. So students going into the animal studies building, or the plant industries building, or the agribusiness building, or the cafe, or the library, or the health centre. I mean, I'm not sure about whether we put one in the health centre, but you know, they can go and they touch on demand. They can look at their courses, they can look at the data, they can look at how the information is developing around that particular component of the campus. As I say, that's some money that I'm going to have to look for somewhere else. But we were very happy to get this money. It's a nice of money for 18 months, and I think we can, hopefully with Libellium's involvement, because we really are working quite closely with Libellium on our technology, but also on how do we provide value to them and get them involved in the projects. And they have very strong links with Blackboard already. So this could be a very, very big long-term sustainable project, I think, for all of us. And that's the end. So that went quite quickly. I don't know whether I went too fast. I'm very happy to answer any questions or go back over something that people didn't get hold of. Anyone want to put up a hand? I'm not hearing, although I can hear someone in the background, I'm not hearing anyone. Matt, can you hear?
Yeah, I can hear you, but no one else has requested to talk yet, that's all.
Okay. So Gizzy's chatted, Sally Jordan's chatted, Tim Hunt hasn't, David is still listening, I think.
So Jeff has asked a question down in the chat. Okay, someone has pressed the what do you call it? Ding ding button. Jeff,
yeah,
would you like? Yep. Jeff, if you'd like to take your mic.
I can't hear Jeff, Matt.
Yeah, I can't hear him either. Geoff, your mic's not working properly, I think. All I can hear is something that sounds like little mice whispering and down in a very low corner somewhere, so you might want to check the volume. So Kim, Geoff was asking about assessment. So what kinds of assessment you foresee perhaps that might be used with this kind of live data?
Well, again, for me, assessment becomes an issue for innovation. We have to do something about assessment that actually makes it interesting for students to do, in totally engage and not forget after they've just rushed off their quick assignment at the last minute. So my thoughts are the problem-based learning modules could actually become part of the assessment. So you actually have a problem that it's using real-time data, you could then set an assessment around that problem, or you could actually get them to use the real-time data that's coming in through that Blackboard module to actually do an assessment piece on, for example. I mean, I could use it in precision agriculture because I could get them to say, look at soil, rainfall, humidity, and get them to look at spatial variability over the whole campus, for example, in that. So we take that data and we could put it into a GIS, or someone could easily put it into a series of graphs, but then get students to examine those graphs for and create some issues that they want the student to look at. I'm open to any sort of assignment. As I say, we only got the money on Wednesday, so we haven't even started really seriously talking to the academics as to what they want, other than what they've given me initially. So the assessment aspect of this is something that is still really to be explored.
I think some of the aspect is it's quite new, so the academics might not know what the system is capable of, I think. So I guess trying to think up some good examples to give the academics ideas about how they can, go a step further than just the standard assignment.
Yeah, no, I agree. I mean, one of the things that I suggested to the chemistry lecturer who didn't think he could use any of this data for anything was the fact that if he was looking at chemical content, chemicals, he might be able to look at the ring tank versus one of the troughs on the livestock and see what the quality of the water was like, and ask students to work out why was the pH of water, you're getting all the chemical content coming through, why was the pH of the water as it was. Alternatively, that person could perhaps work with a farm manager to create a situation where there was some runoff into one of the dams of agricultural inputs, and you could monitor that over time and get the students to look at the issue of runoff over time. These are very early thoughts, but there are many issues in the environmental and agricultural sector that you can look at, interact with, investigate if you've got real-time data.
Sure, yeah. Tim's made an interesting comment. Of course, we shouldn't be starting from the system capabilities, but look at the kind of problems that we would like to solve. So as you say, in the environmental area, what sort of things, what sort of issues are out there, and then see if the technology is capable of making that more possible. So
yeah.
That's a good comment from Tim.
It's a very good comment. Yes, I'm just about to say yes, agree completely. But very often, you are blowing in the wind when you suggest something like this, if you actually haven't got the system in place. And part of the issue is that if you're doing it just as a small experiment in one course, it dies as soon as that person goes. What I wanted to do was have an infrastructure that is available across a campus, that if we can make it work for this campus, then we can actually put it on, say, the St. Lucia campus or any other campus, quite frankly, to be developed up for various issues that people want. So if we're in tropical agriculture up here in Queensland, down south, or in the UK, or in Europe, or wherever, you're looking at different types of agriculture. So you would think that there would be different issues at hand. Frost, for example, we don't get frost in Queensland, but they do get frost in South Australia and in Europe. We don't have such a great salinity problem up here, but in Western Australia they have a huge salinity problem, and it's a growing area of Australia. So there are, with a system or with the data more like from a system, you can then start to also then be a bit more credible when you start talking to people about how they might want to use it. But completely agree that you have to have problems, absolutely.
Geoff also asked earlier that are you collaborating with other institutions with, who have similar kinds of setups or perhaps complementary setups?
Not yet. It has been a very fast startup. And from my perspective, I actually don't. I know UTS has got a very intensive smart city set of nodes going on, but as far as I know, there isn't any other organisation in Australia that are doing such a wide, comprehensive data collection scenario. I mean, we're covering gases, we're covering water, we're covering land, we're covering solar radiation, etc. So I don't think there's anyone at the moment that's got such a comprehensive. But David Bryceson might have a better answer to that. David, have you got a better handle on that?
David, if you want to speak, you need to press the talk button in the upper left-hand corner of the screen. Then you should be able to use your microphone.
Yeah, I think he's chatting. He's going to chat, is he? Sorry, no mic on PC. Okay, can you answer that question on the chat? Who else is doing this stuff? Or what? I'm absolutely sure there isn't anyone doing it in the degree of intensity that we're looking at here in Australia. I know UC Davis is engaging with you guys at Librarian, but I'm just not sure how far people have gone down this track.
Tim also mentioned, actually it's a good idea, the webinar we ran on the 6th of May about the 4D visualization environments for the agriculture as well.
Yeah,
so can you imagine things like, rainfall or time series data being able to be presented in their visualization environment as well?
Absolutely, absolutely. I mean, that really is, that starts making it much more real. I remember in Australia when the Southern Oscillation Index was just becoming, was just being developed as a way of looking at whether we were going to have El Nino or not, and that was all about visualizing large data sets. It was, and then the ABC News got hold of it, and then it becomes an absolute integral part of the forecasting mechanism for El Nino. Then, so it's been done. It's just we're trying to do it on an educational arena as well.
Sure, this is more of a local scale as well, like within the region rather than across a whole continent too. So,
Gizzy has just asked me, hang on, do you link or collaborate with Oz equivalent educational levels for FE colleagues locally with this environment and sustainability sounds very hot and seeing potential options for exploring degree and beyond? We're working with our environment group here at UQ. And yes, I would be, as I say, this stuff will be publicly accessible. I'm wanting it to be that. It is a resource for education from my perspective. We can do lots of research, but it's a resource for people that have got great ideas about how we might use this to use the data and then perhaps share their knowledge after they've started doing it.
There was also a similar suggestion for the school kids as well, getting school level involved in, particularly for the STEM students, making this more relevant, interesting, etc.
Look, I host regular school visits onto the campus, and this is one thing that I am starting to talk to them about. Again, until we get some decent visualization up, it's a bit too academic for school kids, but once we get some really nice, cool visualizations going, I speak to their teachers, and it would be one thing that we could enable and access, not a problem, and that would then lead, hopefully, what you're doing now is essentially interesting kids at high school to then come into the university system, which again is one of my goals, is to get more kids into this area. 16 to 18-year-olds, yeah, no, that's fine. I agree. Many youth are setting new masters about IoT. Yes, they are. But remember, this is not IoT. Well, I have to say that I am collaborating with one of the professors in our school of RCS, and she is into IoT in a very big way, and we are looking to involve all that in the agri-food chain. But that is pure, that's research. It's not the educational aspect.
Okay, so do we have any other questions, folks? Otherwise, we could potentially finish up.
If anyone's interested in contacting me, I'm more than happy to talk about this in a more, slightly more, I'm still trying to fiddle with the technology, so I'm a bit all over the place. I do apologise. I've enjoyed putting it together and having the opportunity, but I'm more than happy to talk to people about this, offline, so to speak, via email and Skype. And certainly make people aware as we go with how we're going with developing this, the input of this data into. I'm not just going to do it on Blackboard. I mean, that's fine, but the idea for me is, as someone said, can I use it on a mobile phone app? Absolutely. So I have one of my first year classes developing mobile phone apps in electronic technologies and agribusiness. And, they know how to do it. So we need to be producing this stuff for them in the app world. So believe me, it's been a long time coming. It's been me working out how to strategize within the university environment and find out where the funding is. Okay, well, if that's all, as I say, please contact me if you wish. I'd be more than happy to chat long and hard, and I hope you enjoyed it. Thanks very much.
Yep, thanks, Kim. I'm going to stop the recording now, but people are welcome to stick around. Just before you go, though, if you could go to our feedback link. There's a link on the screen there, ta.vu/feedback. It's a live link. You may click it. So thank you very much for joining us, and we'll see you all again, hopefully in a month's time, for the next webinar. So thanks again, Kim.
Thanks, Matt. Appreciate it. What do we do? Do we hang around now?